These are some homework problems on section 1.2 that some people had some questions on, so let me kind of go through the solutions. Number 12, it says just identify the domain range and sketch the function. Well, I'm going to probably sketch it first. Now this looks like just good old what we call double swoosh. That's one of our parent functions. And if I graph this, I know this is going to be, it's going to have a vertical asymptote at x equals 0. And it's also going to have a horizontal asymptote because the degree of the top is smaller than the degree of the bottom at y equals 0. So it looks like this. So this is what we call double swoosh. Swoosh is just 1 over x, which goes like that and like that. So you can see the domain for this function is all x except for x equals 0. So x, you could say the domain is either x is not equal to 0. That's one way to write it. Or so there's a couple ways to write the domain. Now, what's the range? Well, the range of this function is going to be 0 to infinity, but we're shifting it up 1. So it's just going to be shifted up 1. So if we want to sketch the graph, this is y, this is x. So you could put the line, we could call this 1. And then you could write maybe an asymptote because this is asymptotic because the degree of the top is smaller than the degree of the bottom to the line y equals 0. So now we're just moving it up. We're shifting it up 1, so it's going to be asymptotic to this line y equals 1. And it's going to have everything will be almost the same. It's just shifted up. So as far as the domain is concerned, the domain would be the same. But that's what it would look like. And the range now would be the interval, and it's going to be not equal to 1, so it's going to be, oops, that was wrong. I'll just scratch that out. And the range will be open at 1 and going up to infinity. Okay, so if that makes sense, that's number 20. There's your sketch. And then number 12, that's number 12, looking ahead. Number 16. Now number 16, it says use a grapher to identify the domain and range. So you could use your calculator. You could actually figure this one out, I think. We've done this before. It looks like it's a y equals the square root of 9 minus x squared. So if we square both sides, we get y squared equals 9 minus x squared. If we add x squared to both sides, we get x squared plus y squared equals 9. And that's just a circle whose radius is 3, but this is a positive. This is the upper part of the circle whose radius is 3. So if you wanted to sketch it, you could probably sketch it without even using your calculator. Y, x, always label your axes. Oops, minus x. And we go out 1, 2, 3, 1, 2, 3. And x can be 0. I'm sorry, x could be 3 because 3 squared is 9, 9 minus 9 is 0, and the square root of 0 is okay. So it's a semicircle, it looks like that. And then you can see the domain is going is -3 to 3. And the range is going to be 0 to 3. And you could just kind of do that without a calculator because it's pretty straightforward. Okay. But we could look at it. The calculator might be kind of interesting to put this in so you can see what's going on with these things here. So turn it on. and go to y to graph it. And it's going to be second square root, second square root, and it's going to be 9 minus x squared, 9 minus x squared, parentheses, and I'll do that zoom 4 because that should work. And there's your top part of the circle. Now if we wanted to see the whole circle, which wouldn't be a function, but it would be a relation, then just go over to the y plot again, and then just put the negative square root and use the little negative sign down at the bottom. There's a little negative sign down the bottom we use for a leading negative. So use that little negative sign right there. And then do the same thing, second square root, 9 minus x squared, parentheses. And then when you graph that, there's the bottom part of the circle. That's the negative square root. And if that doesn't look like a circle, then you go zoom square and that will. Because if I went zoom 4, it might not look, well, it looks pretty much like a circle. But if you go zoom square, that's 5. Makes it, squares it off. Even a little bit better. Okay. So that's 16 and number 12 and number 16. So that should be sufficient to clear that up.